The purpose of this video is to look at composition of transformation to see if we can express that composition as a single transformation. And I'm going to go ahead and jump right in here. Number 1 says, by looking at the figure and its images on the graph, can we determine a composition of transformations that creates triangle J double prime, A prime double prime, U double prime? So I'm going to start, first of all, by examining the pre-image. And the pre-image in this particular case is going to be triangle JAU, that yellow triangle. We want to know what transformation brought the yellow triangle onto the blue triangle, triangle JAU prime. So in looking at that, the first question we're going to ask ourselves is there a transformation that will map the yellow triangle onto the blue triangle? And in fact, there are 2. One of which reflects that triangle through the origin, the second of which rotates that triangle 180 degrees about the origin. So in moving from the yellow to the blue, there are 2 possible transformations that we can use to take us there. We can say, first of all, if we want to talk the point reflection first, reflecting through the point 0, 0 of the original triangle, triangle JAU, that will result in triangle J prime, A prime, U prime. Now, if you weren't in the mood for reflecting through the point, you could also rotate that triangle 180 degrees about the origin. So a rotation about the origin of 180 degrees of triangle JAU would produce triangle J prime, A prime, U prime. The second thing that we did here is we took this blue triangle, and from that blue triangle, it was transformed in some way, shape, or form to get the green triangle. So that one I think is a little bit easier to identify. All they've done is flip the blue one over the y-axis, and from that they've obtained that second triangle. So that's a reflection over the y-axis of triangle J prime, A prime, U prime. That results in triangle J double prime, A double prime, U double prime. So in determining the composition, we did 2 things. Either first we did this rotation or the reflection, and then secondly, we reflected across the y-axis. So to write this in composition notation, I'm going to say a reflection in the y-axis following either the rotation or the point reflection. It's your choice. I'm going to do the point reflection of triangle JAU produces or creates triangle J double prime, A double prime, U double prime. And again, if you had preferred, you could have written that as the reflection in the y-axis following the rotation about the origin of 180 degrees of triangle JAU will produce triangle J double prime, A double prime, U double prime. So either one of those is an acceptable way to write the composition of transformations that carries triangle JAU onto triangle JAU double prime. All right, the second part of this question I think is actually a little bit easier. What single transformation will map triangle JAU, the yellow guy, and that should say triangle JAU, onto triangle JAU double prime? So what single transformation will map the yellow triangle onto the green triangle? And the simple way to express that is a reflection over the x-axis. I'm going to write this in function notation, so I'm going to say a reflection over the x-axis of triangle JAU will produce or will result in an image triangle J double prime, A double prime, U double prime. So this composition that we decided up here in red In the single transformation that we did down here in blue, both result in the production of the green triangle. All right, let's go ahead and take a look at example 2. Before we do that, if you have questions, if I said anything that doesn't make sense, make sure that you jot a note in the margin so that you can remember to ask about that the next time you come to class. Number 2, we're going to do something similar. It says triangle ABC has those coordinates. Part A says sketch and label the triangle. So the first thing I'm going to do is plot those points and sketch the triangle. So there's point A. There's point B. There's point C. Part B says graph and state the coordinates of triangle ABC prime, which is the image of triangle ABZ under a rotation of 90 degrees about the origin, following a reflection across the x-axis. So I'm going to go first of all, and I'm going to reflect point A across the x-axis. Once I reflect it across the x-axis, I'm going to rotate it 90 degrees. So when I reflect point A across the x-axis and then rotate it by 90 degrees, I end up at the point whose coordinates are 4, -1. Point B, I'm going to do the same thing. I'm going to reflect it across the x-axis and then rotate it by 90 degrees. And I'll give you a minute so that you can do that and figure out what the coordinates of point B prime should be. Hopefully you ended up with the point whose coordinates are 7, 3. If you didn't, make sure you make a note so that you can ask me about that the next time you come to class. I'm going to go do the same thing. I'm going to reflect point C across the x-axis and then rotate it by 90 degrees. Okay, hopefully when you perform that composition, you ended up at the point whose coordinates are 1, 5. If you did not, please make a note so that you can ask me about it when you come to class. All right, so I'm going to go ahead and plot those new points now, and I'm going to do this in green to differentiate the original triangle from our transformed triangle. And like they did in the first example, they're asking us to now find a single transformation that will be the same as what happens if we do a rotation of 90 degrees about the origin, following a reflection in the x-axis. And if I come over and look at the picture and try to use the same approach that I used in the first example, just by looking at it, it is not immediately apparent, not immediately obvious what happened to these two triangles. So that strategy that worked for me in the first example isn't so effective here. So what I'm going to do for this particular example is I'm going to go pay attention to the original coordinates for point A and what happened to those coordinates after the transformation was complete. I'm going to go look at the original coordinates for point B and notice what happened to those coordinates after the composition of transformations. And I'm going to go look at the original coordinates for point C and look at what happened after the composition of transformations was completed. And I noticed that in each case, the x values and the y values have been switched. I also happen to notice or know that that's what goes, or that's the rule that you use for reflecting a point across the line y equals x. So the single transformation that's going to be equivalent here that was performed is a reflection across the line y equals x of triangle ABC, and that resulted in our new triangle A prime, B prime, C prime. So actually the single transformation that was performed was a reflection in the line y equals x. All right, folks, if you have questions, make a note of it. I know there's another example on the next page, but we are going to call it a day.